Let's have a look at the base capabilities. So there you go. We've got a box at the bottom there, which is representing 3GPP release 15. So the initial 5G specifications, which was really good and did a good job at supporting the existing traditional broadband business model. But since then, in the newer documents, the newer releases, so through release 16 and 17, and then release 18, 19, and 20. Although bear in mind, remember, we're just at release 18 at the moment. What we've done is we've improved the system. So just taking spectrum related issues, we've got new license spectrum options introduced throughout those different documents. We've got use of unlicensed spectrum, which is some really good use cases there. We've got interference management, which has been really beefed up since the initial release 15 documents. Now, some of this may mean something to you. Some of it is more specific to the radio engineers, for example. We could look at the air interface, and we've got something called a two-step random access. What on earth does that mean? Well, if you're a radio engineer, you'll probably know what we're talking about there. If you're not a radio engineer, what I will say is that, for example, if we start introducing satellites into the system, so to connect into the 5G system via satellites, there's some real specific things we need to think about. One of which is, how long does it take a device to connect to a satellite? Actually, this improves that process for satellite access. You've got things, these are only examples, by the way. There's a lot more spectrum related things which we've developed since release 15, but these are just some examples. Same with the air interface, just an example. Then the radio access network. So we've got something called integrated access backhaul, which we've developed over the last few releases. So integrated access backhaul, this is where you might have an existing base station in an area, but to put more capacity in place, perhaps you've got a sort of shopping mall or a cafe area, to put a lot more capacity in place for people to watch the videos as they're drinking the coffee. You might want a smaller base station outside each cafe, but you really don't want to dig up the pavement to put in fiber optic cables to connect those base stations. So what you can do instead is you can actually use radio. So from that main site, you can use the 5G spectrum itself to connect those smaller cells. And then we've got the core and the service aspects. Now, remember, all of this is about just improved base capabilities. So how has 5G generally improved? So we've got more end-to-end options in terms of the end-to-end bearers or the end-to-end connectivity we put in place through the network. We've enhanced something called the service-based architecture, which is the architecture itself, the way in which we connect those core network elements. So in the old days, we used to have telephone exchanges. Now we've got lots of different network functions, which are being connected in specific ways, which collectively give us what's known as a service-based architecture, much more efficient, much more effective. And then we've got the possibility of telecoms operators interacting with third parties. So, for example, if you're asked as a telecoms operator to support BMW as an auto company in your country, there's going to be lots of interaction between the telecoms company and BMW. So the network exposure really relates to how the two entities, the telecoms operator and in this case BMW, might communicate. So as I said, these are just areas that have improved over the years as we move into the 5G advanced era, shown in light green there. But there's lots more. The 3 dots in each case just show that there's lots more there.